Now, the hardest part, I believe, they're not really hard, but it's harder to predict if you have a single replacement.
Yes. The single replacement, there's two things about single replacements. The first is you could be replacing a metal with a metal, or a cation with a cation.
Right. Those are both metals, so you
Right.
would swap those two.
Right. Or you could be replacing a non-metal with a non-metal.
Okay. So if we have magnesium chloride and
It's
fluorine
fluorine
gas?
Yeah, fluorine.
And fluorine's a diatomic, so it's going to be F2.
Beautiful.
All right. Now, in this case, here we had two metals.
Right.
Here we have two nonmetals.
Exactly.
So in this case, it's these nonmetals that we'll swap.
Right.
So we have to look and see what we've got.
Exactly. We have to look and see, first of all, what we're going to swap out. Okay, that's the first thing.
Okay, because there's no such thing as CuAg.
Right. Right.
And there's no such thing as ClF.
Okay. The next thing with single replacement reactions is something that we call the activity series.
Activity, okay.
Okay.
Activity.
And what that is it's a list of the metallic elements or the halogens. It's two different lists.
Okay.
Organized in the order of ease with which they undergo chemical reactions.
So some things are much easier. For instance, fluorine really, really, really wants to react.
Correct.
Bromine isn't quite as reactive.
Right. So we use their place in the series versus we use the position of the one we're going to replace with the one we want to replace it with. We use their positions in that series to determine whether or not the reaction will actually occur.
Okay, so like on the last slide that we had, we think that the copper is going to take the place of the silver.
Right.
But we need to look and see which one is more reactive.
Right. And if the copper is more reactive than silver, then the reaction will occur.
Okay.
But if the copper is not as reactive as the silver, then the reaction won't go, and you would write NR on the other side of the arrow for no reaction.
No reaction. All right. And in the case with this is the same.
Yes.
If chlorine is more reactive, then it's not going to...
It won't go.
And if fluorine's more reactive, they will swap places.
Right. Now, the nice thing about the halogen series is that the halogen activity series goes in the same order as the halogens on the periodic table.
Okay.
So fluorine is the most reactive, then chlorine, then bromine, and then iodine.
Okay.
So all you have to do is look at the periodic table, and there's your activity series for your halogens.
Okay. So if we looked at this, we would say, for instance, here, chlorine is not as reactive as fluorine. So they are going to want to swap places.
Exactly.
Okay. If we had, however, if we had
this.
Exactly. That's not going to react because chlorine is not as reactive as fluorine.
Right, so you're going to draw a big capital NR on the other side of that arrow.
All right.
There we go, no reaction.
Okay.
Okay. So, let's go...
we have a list here, and this is a little hard to read, but this is what we just kind of drew.
Right. Now, we will have, for the students, we'll pass out to them their own copy, but we also have laminated copies that they'll have for their tests.
So they don't have to memorize this?
They don't have to memorize this.
So if it's farther on the left here, in this particular one, it's more reactive.
Correct.
Okay.
Now, the list they'll have will be a columned list that will
Like
have
up and down?
Right, up and down, and it will have the most active on top and the least
So
active
more like
on the
this.
bottom.
Okay.
Exactly.
And so the easy way to do that is, if this thing is on top, it's going to react.
Correct.
Okay? In this case, if the single thing here is on top, it's going to react.
That's right.
Okay. If this is on the bottom, if it's below this, then it's not going to react.
That is it.
All right. So we'll do some samples of those while we're in class.
Yes.
All right. But that students might want to go ahead and write these into your notes, at least these 2 bullet points here. All right. And that should help them understand the idea for this single replacement.
And the way to really get good at this is just to practice.
Okay.
And if you want additional practice outside of the homework, please come see me or Mrs. Baxley. I have tons of extra worksheets.
Nice.
So we have all kinds of things that they can use.
Okay.
Okay. Let's see. Do we have? Okay, we have silver and copper nitrate, and it says no reaction.
That must mean that
silver,
this is more reactive than the silver.
That is correct.
Okay.
That's correct.
Our next example, it's already done for us, and this does react.
Right, because fluorine is the highest in the activity series, so it will naturally replace bromine. So you get the single replacement reaction to
So
occur.
these two are swapping.
Mhm.
This one is higher up, so it's going to react.
It's going to react.
All right.
Let's see what we got next up. Okay, bromine. This time bromine's trying to replace fluorine, and that's not going to go because bromine's lower in the activity series than fluorine, so there'll be no reaction.
Okay.
So, and again, the only way to really get proficient at this is just to practice.